I think stats 1 is still going on, right?
Actually, sir, the link is not on YouTube and not active on YouTube. Actually,
YouTube, we didn't start yet, I guess. It will start at 8.
yes, because sir, I am traveling and my data is not filled. Yes, sir.
Okay,
Yes, sir.
YouTube, we will start streaming at 8 p.m. exactly. It will start now. Okay.
It's showing already started.
Yes, yes, sir.
No, it's not started yet. About to start now. Is my voice audible?
Yes, sir.
Hello. Yes, right.
It started, sir. Thank you, sir. It started,
Okay.
sir. Thank you.
Okay. Okay, let's wait for some 3 to 4 minutes before we start because I guess stats 1 is still going on and many people are in stats 1.
Yes, sir.
Hello. Yeah, hello. Am I not
It started, sir. Thank you.
Okay, let's wait for 3 to 4 minutes before we start. Okay, today we are going to discuss some 5 questions which are pretty much uh, similar kind of questions
Sir,
of
can you
graded
discuss some
assignment week 8.
activity? Yes, sir.
Yeah,
An activity
once I'm done. Yeah, activity question.
activity case.
Aditya, am I the only one who can't hear Aditya properly, or is it Aditya's
Sir, same.
connection problem or
It's from
mine?
his side, sir. It's from his side.
It's from its side, right? Okay. Do one thing, Aditya. Whatever the question is, just post it on the chat.
Okay, sir. Okay.
Yeah. So I can't hear you properly. So that is the issue. Okay. Yeah. So our main agenda for today's session is we will discuss some 5 questions which are replicas of graded assignment questions. So that once we solve these questions today, that will help you to answer or solve some of the graded assignment questions in week 8. Okay, once we are done with that, then we will go to I will make it as an open session. So there you can ask whatever the doubts you have in week 8. If we are done with week 8, we can go back week 7, week 6, like that. Okay, clear?
Yes, sir.
Okay. Okay. Is my
Hello, sir. Hello.
hello?
Yes, sir.
Yes, sir.
Okay. Am I lost connection in between?
Yes, sir.
Yes, seems so.
Okay. Okay. Is my screen visible?
Yes, sir.
Yes, sir.
Okay. What I wanted from you is just open this joinpd.com and type this code ONOVQP, which is visible on the screen. I request everyone to open this joinpd.com. You can use it in both, whether it is mobile or laptop. Okay, I hope now I am clearly audible to you guys. I have changed my network. Yes, no, thumbs up, thumbs down.
Yes, sir, you are pretty much audible.
Yes, sir.
Yes, sir.
Yes, audible.
Okay. Yeah. Okay. Okay, then let me start this session. Let us start this session. And meanwhile, rest of the guys, please join this joinpd.com and type this code ONOVQP. Even after that, it will be visible on the right top. You can see on the right top. So the code is visible. So today we are going to do some questions. Yeah. Any pre-doubts? Pre-session doubts?
Sir, you can throw some light on derivation.
Okay. If there is a question on that, we will discuss some topic around that and we will solve the question.
Okay, sir.
Okay, let me make this full screen and we will start. Okay, yeah. So my name is Srikanth Venkateshan. I am one of the course instructors for mathematics course. So today we are going to discuss few questions of week 8. Okay. Without any delay, we will start our first question. So here is 3 columns given to us. The first column, we have given you the functions, and the second column, so whatever the first column functions are, and the second column have tangents at 0, 0, and the third column is the graph of the tangent as well as the function. What you have to do is you have to match the respective function to its tangent at 0, 0, and the graph, corresponding graph of the function as well as the tangent. So here the options are given to you, 5 options are given to you. So out of the 5, what I want is, if your answers are 1, 2, 3, just type 1, 2, 3. So if you feel answers are 2, 3, 4, it should be like 2, 3, 4. So comma between every option. So that is how your response should be. Okay. Let me give you some, maybe 5 minutes. I hope the question is clear to everyone.
Yes, sir.
Yes. Okay. Now take time to solve this and let's discuss the answer after 5 minutes. Okay, those who have joined late, so if you want to answer this question, just open new tab and type joinpd.com and type the code which is visible on the top right, ONOVQP, so that you can also see the same slide on that site and you can answer there.
Hello, sir. Can I ask a general doubt?
Are you done with this question?
Yes.
Okay, then okay.
Sir, do we have to memorize all the standard derivatives for the exam purpose?
You mean, see, we have discussed only very few functions, right?
We saw in exam more complicated derivative. If we go by first principle or other method, it will take time. So we have to memorize it.
Can you give me one example?
Uh,
Much complicated derivative.
Yes, sir. Like in practice activity, there is a derivative of tan inverse x. So if we memorize the formula, then it will very easy. But if we go by first principle, it will become very complicated.
Okay. So as far as quiz 2 concerned, I'm pretty much talking about quiz 2 related. Okay. It's not about the course. So whatever needed in quiz 2, we will give you. If it is needed, we will give you the standard derivative.
Okay, sir. Just we have to apply basic chain rule or.
So the composite rule or the chain rule you have to use.
Okay. Thank you.
If required. If not required, we won't give you. Okay.
Okay.
Quiz 2 would be up to 8 weeks, na?
Yeah, week 8 till week 8.
So we still need to complete week 9.
हाँ उस टाइम तक week 9 भी हो जाएगा लेकिन there will not be week 9 related questions in quiz 2.
But we have to submit the assignment, sir.
Yeah, you have to submit the assignment. It is like a regular thing. You just have to submit the assignment.
Okay, sir.
So graded assignment deadline will not be postponed.
But in the meanwhile, we have to prepare for this
Prepare
exam.
for exam also, correct. So we will have revision sessions, everything.
Just like before quiz 1, sir.
Just like quiz 1, we will have the same 2 sessions of revision. One will be on mock and second one will be on complete revision of weeks 4 to 8. Not from 1 to 8. We will have weeks 5 to 8.
Is it quiz 2 is from week 5 to 8 or from 1 to 8?
It will be like 1 to 8. See, whatever the concepts we are going to use in 5 to 8, it actually uses 1 to 4. Right? Whatever the function we deal, so those are already we studied in polynomial or the straight lines or the quadratic functions. These all are we studied in week 1, week 2, week 3, week 4, right?
Sir, once you take the class about the graphs, sir, all varieties of graphs. And in that graphs, tangents, continuity, differentiability.
Okay, I guess there are some on-demand sessions, right? Maybe in that sessions we will come up and we will deal those things.
Thank you, sir.
Yeah. Or else if we are done early today, we can discuss today itself. Okay.
Thank you.
Sir, the concept of week 1 will be merged with all these weeks, means week 4 to 8, or it will be a separate. Okay, got it. So basically it will be something like what we are doing right now.
Correct. So whatever the question you see that more of uses week 5 to 8, it may use, we don't have direct questions from week 1 to 4. That is what I wanted to say. There will not be any direct question from weeks 1 to 4. But the question you might use week 1 to 4 concepts in that.
Like we always do in this. Even
like
in this question also we use it.
Correct. Even in this question also you can apply that concept. So that is how it will be. So more of all the questions will be from week 5 to 8, but some in one question or maybe 2 hardly. You might or you can use weeks 1 to 4. So you shouldn't complain, right? Like that is why in order to remove some complexities, we say week 1 to 8 is the syllabus, but we more emphasize on week 5 to 8. Like if a question is without our knowledge also, it might come from week 4 or week 3, and you might complain that that is out of syllabus or something like that.
So weightage will be equal to now first week, second week 50%, and third week, fourth week 50%, right?
We will discuss those in revision sessions. The complete some blueprint kind of thing we will discuss. Okay.
Done for this question.
Yeah. So let us discuss. Yeah, where to give the answers? Yeah. Okay. So fellow mates have answered it already. Okay. So what is the key idea, or how should our approach be to solve this particular question? So
The
main
tangents are basically derivatives, so we should calculate the derivative at point f of 0, then only we can find the
correct.
tangent line.
So in order to find the tangent line, what we have to do, we have to derivate the function and substitute the value of x. So you will get the slope. So once you get the slope and also the point 0, 0, you can find the equation of the tangent. Right? Once you get the tangent, you match column A with column B. And how do we match these two to column C?
Looking at the graph also, and even what is the f of x is there.
Correct.
For
So,
the second one, it is a cubic function. So, and for next one also, it is a cubic function. First one is an exponential function. So we should know the graph. Concept of week 1.
Concept polynomials. So week 4 we have studied. So if a polynomial graph function is given to us, how will be the graph is? So if you know from there, so this is a standard, the second function which you are seeing. Hello. Aditya, I request you to post your question via chat maybe. So because you are traveling, I can't hear you properly. Okay. So
actually I'm traveling, sir. That's why there is some
yeah. I understand. That is why I ask you to communicate through chat. Okay. So we have to use some knowledge which we have taken from week 4 in order to answer this particular question, in order to match column A with column C. So this graph, the second row graph function which you are seeing is a standard cubic polynomial which is x cube minus x. So its roots are 0, -1 and +1. And the graph is a cubic polynomial. It will be like this. So there will be a 2 bends, and as x tends to minus infinite, our function value will go to minus infinite, and as x tends to plus infinite, our function value will go to infinite. So the leading coefficient is positive, as well as it is an odd degree polynomial. So the graph will be of somewhat like this. And also you can see the third function is actually the minus of the second function. So it's actually the reflection with along x-axis. So if you wanted to, can everyone please be on mute? Akash Pandey, please, can you? Okay. So the function has leading coefficient as negative, as well as it is a 3-degree polynomial with roots 0, -1 and +1. So the graph will be somewhat like this. So now that we know 3 will map to 2, 2 will map to 1, and the left one is like x times 3 to the power x. So x is an increasing function. 3 to the power x is also an increasing function, exponential function, we know that. So product of two increasing functions will be an increasing function. So if you see from the 3 graphs, directly you can say this graph is not completely increasing function. Even this is not a completely increasing function. So the third graph is an increasing function. So 1 maps to 3, 2 maps to 2, 3 maps to 1. And now that we have mapped column A to column C, so let me see answers first, what you have given. So 214, 214, 124, 124, 214. Okay, most of you have given 124. Nice. Looks like 124 are the answers.
Sir, 2 maps to 1.
Yeah, 2 maps to 1. So this function maps to this graph. And this function maps to this graph. So 3 maps to 2. So if you see from the options also 3 maps to 2 is only one option, option 4. And you have to check whether 3 maps to C or not. So for that we have to do this. So we know the given function. We have the function with us. And the function is, so you have to apply the same for every function. Okay. I will tell you one function how to do. Rest 2 functions are same to same. So how we find the tangent of any given function at any point. This is how you have to do. So you have the function with you. What you have to do is you have to derivate the function. So as these are very easy functions. So for the first function, x times 3 to the power x, it is like product of 2 functions. You have to use the product rule of the derivative. So f g derivative will be f dash g plus g dash f. So now one function is x to us and the other function is to the power x. So use that product rule. Okay. Use that product rule. So you can find the f dash of x, that will be equal to 3 to the power x plus x into 3 to the power x. So now this will be the derivative function. Are you able to see that? I'm not able to see that. Yeah.
Yes.
So f dash of x will be 3 to the power x plus x times 3 to the power x, and the derivative of 3 to the power x will be ln 3. ln 3 3 to the power x. I hope you know how to find the derivative of exponential function. Exponential function a to the power x.
Yes, sir, we know.
Yes, right? A to the power x will be ln a times a to the power x.
Yeah.
So the same thing here. So now we need to find few values in order to compute the equation of the tangent. So one thing is, once you find the derivative function, if you substitute the x coordinate in the derivative function, you will get the slope of the tangent. Correct? At that particular point. So for this, if I substitute x is equals to 0 in the f dash of x, so the value which I am going to get will be the slope of the tangent as well as the slope of the function at that particular point. Both are same. Okay. Okay. I just wanted to show it. Is my journal screen visible?
Yes,
This
sir.
white
Yes, sir.
ruled paper kind. Yes.
Yes, sir.
Okay. So what I wanted to tell is, convey is, if I have any function curve like this, and this is the point where I wanted to find the tangent of the line. So the tangent will be somewhat like this. So let us say this is function, some function f of x, and the tangent line something like L of x. So what I said is, let us say this point is actually some x is equals to a. So what I said is, the slope of the tangent line L of x, this L of x will be equal to the slope of the function f of x at x is equals to a will be equal to, this both will be equal to f dash of a. Okay. So this is what I said. This particular curve ka slope at this particular point x is equals to a, and also the slope of this tangent line, both will be equal to the value of the derivative function at x is equals to a. So f dash of a. This is what we use there. So in order to find the tangent line, what we did is we have found the derivative function f dash of x, and we will find the value of this f dash of x at x is equals to 0, because we are trying to find the tangent at 0 comma 0, point 0 comma 0. So we will find the value of f dash of x at x is equals to 0, and that will be the slope of this line, slope of the tangent line. So once you have the slope of the tangent line, so now we will have the slope of this line as well as the point. So this point will be a comma f of a, right? As this point is on the curve, on this curve, so this point will be a comma f of a. But in our question it is given, the point is also given to us, it is 0 comma 0. So we know the point and we know the slope also. Slope will be f dash of 0. So once you know the point and f dash of 0, the slope, so use point slope form which we studied in week 2. So if you know the point, if you know one point on the line, and as well as if you know the slope of the line, then using the point slope form, the equation of the line can be found. So L of x will be equals to the slope f dash of 0 into x minus a, or the point. So here it will be f dash of a. Here if we are finding the point is a comma f of a, and the slope is f dash of a. So now the equation will be L of x is equals to, so the L of x minus f of a is equals to f dash of a times x minus a. So this will be the point slope form, right? Y minus y naught is equals to, so the slope m times x minus x naught. So if you remember, here it will be y is nothing but L of x, or the L of x, and y naught is the point, y coordinate of the point, so that will be f of a, and f dash of a is nothing but the slope here, x is x same, and x naught is the x coordinate of the point, so it will be x minus a. So if you simplify it, it will be like L of x, which is equal to f dash of a times x minus a plus f of a. So this is how the tangent line, equation of the tangent line can be derived or can be understood. Okay, so let's go back to our slides. Okay, so in order to find the equation of the tangent, what we require f of 0 as well as the f dash of 0. So f dash of 0 is the slope, and f of 0 is the y coordinate of the point. So f of 0 will be 0. Hence the equation of the tangent at the origin is y minus y naught. Here y naught is 0, which will be equal to slope times x minus x naught. Slope is 1 here, and x minus x naught is 0 here. So it will be here I am referring to here. So y minus 0 is equals to 1 times x minus 0. If you simplify it, we will get y is equals to x. So y is equals to x will be the tangent line, equation of the tangent line at point x is equals to, at point 0 comma 0 for the function f of x is equals to x times 3 to the power x. So therefore we know this particular function refers to figure 3. So 1 will map to b maps to 3. So 1 is done. Similarly, you have to do for the rest of the things. So here f of x is given to be a cubic polynomial, which is x cube minus x. So the same process you have to follow. So you have to find the derivative of x. Later you have to find f of 0 and f dash of 0, and use this to find the equation of the tangent. So you will get y is equals to minus x in this case. So therefore the equation of the tangent line will be y is equals to minus x. So from there we can say 2 maps to a and a maps to 1. So 2a1 will be our next option. And finally the same thing, if you follow the equation of the tangent for the third function will be y is equals to x at point 0, 0. Okay. So answers are 1, 2 and 4. Done? Shall we move? Any doubts?
No, sir. Yes, move it, sir.
Yeah. Okay. Before getting into the next question, I just wanted to discuss this L'Hopital rule. So it is not L'Hospital or something. It is L'Hopital rule. So S is silent here. So some write L'Hospital and some write L'Hopital directly. So what this rule actually tells us is, if you have two functions f of x and g of x with you, and both the functions you wanted to find the limit value at where x tends to c. So at x is equals to c, you have to find the value of f of x or g of x. So the limiting value of f of x and g of x. But the limiting value of f of x and g of x, if they are tending to 0, both tending to 0 at the same time, or both tending to plus infinity, or both tending to minus infinity, then we have a problem. So in order to compute this particular limit, x tends to c f of x by g of x, in this particular case, if your f of x and g of x are tending to 0 at the same time, or infinity by infinity at the same time, these are called indeterminate forms. So 0 by 0, infinity by infinite. In our cases, what we study is these are the two important indeterminate forms. There are many indeterminate forms. 1 to the power infinite is one thing, and
Yeah, sir. How many indeterminate form we have in our portion?
in our course we have only 0 by 0 and infinity by infinite.
Okay, sir.
Okay, in this particular course we have this, and there are many more indeterminate forms, but it's not required now. We don't
There are
require
total
it.
7 indeterminate forms, right?
Yeah. So I guess so. Yeah. So we don't need all the 7. We need only 0 by 0 and infinity by infinity form. So if it is like that, then in order to compute this limit value at x is equals to c, it will be difficult. So some say 0 by 0, we say 0 by 0 is in an indeterminate form and we can't solve it. But this L'Hopital rule, what it says is, even though if you cannot compute that, if you know the derivative values at x tends to c, like f dash of x and g dash of x, and if you are guaranteed that g dash of x is not equal to 0 in some interval around x is equals to c, then the limit value at x is equals to c for the function f of x divided by g of x will be equal to limit value at x is equals to c. So limit value at x is equal to c or limit x tends to c, both are same. So if I wanted to refer it like limit x tends to c, I will refer it like that only. So limit x tends to c, f dash of x divided by g dash of x, where this particular limit will tend, the value will be equal to the same limit x tends to c for f of x divided by g of x. What if your f dash of x and g dash of x also gives you an indeterminate form? So even after
We have to
taking one
continue.
derivative,
So again derivative.
yeah, you have to take the double derivative. So you have to do f double dash of x divided by g double dash of x, and you have to make sure that g double dash of x is not equal to 0 in some interval around c. So you have to continue, keep on continuing till you reach some determinate form. So till you conclude something. Okay. So in our course also, we not more than 2. We won't go more than 2. So it's like if you derivate it once, if you are unable to get, if you derivate it twice, you will get. 99 cases you will get. Not 99, 99.99 cases you will get. Okay. So this is what L'Hopital rule means. So even though if you cannot find limits for few things using this L'Hopital rule, for some indeterminate forms, we can actually find the limit values. Okay. Now the question is choose the set of correct options considering the function given below. So the function is, so when we give like this, what all these functions, so how do you read these functions? Functions defined, any there is a technical name for this, anyone know?
So
Piecewise
piece function.
function, correct. So piecewise defined function. So when we say piecewise defined function means for some particular interval we define the function will behave in some manner, and in another piece it will behave. Pieces means intervals. So piecewise function, these are called piecewise functions. So this function is defined like if y not equal to 0, then my function behaves like sine y by y. If y is equals to 0, it's a constant function, f of y is equals to 1. So that is how we defined our function f of y, a function f. So what I want is whether this function is continuous or not, whether this function is differentiable or not, and finally whether this function is whether this function contains derivative. That means if it is differentiable, the derivative value at y is equals to 0. So the same thing. So if you feel 1, 2, 3 are correct, so give it as 1, 2, 3. If you feel 2, 3, 4 are correct, 2, 3, 4. Okay. I think 3 to 4 or 3 to 5 minutes is sufficient for to solve this question. Okay, there are few questions in chat. I just wanted to address those. So Manoranjan has asked what is bounded and unbounded function. See, bounded function has, am I audible?
Yes, sir, you are
Okay.
audible.
So bounded functions means if that function range is bounded between two real numbers, like if it is bounded between 0 and 1, or if your range values are between some interval and the boundary points are real numbers, then it is called a bounded function. So if either the endpoints have plus infinite or minus infinite, then those are called unbounded functions. Like the set of range values should be inside one interval. Yeah, Snehadas has answered it actually. And the next question is L'Hopital is valid only for functions which have indeterminate form, correct? So we use L'Hopital only if we get an indeterminate form. If you don't get indeterminate form, you can directly compute the limit value, right? What is the use of taking derivative and computing? Yeah. And other question is like, can you give example some? What is, which example, Jan? Related to which topic? I mean. Okay, I will come to you. Are we done with this question? How many of you done? How many are still doing?
Done, sir.
Done.
Done, sir.
Okay. So let us quickly see this. I don't think. Let me see your answers first. So 2, 3, 2, 4, 5, 2, 4, 5, 2, 4, 5, 1, 2, 4, 6. 2, 4, 6, 2, 4, 6, 2, 4, 5, 2, 4, 6. Okay, I guess many have given 2, 4. But most of you are confused with whether it is 5 or 6. Option 5 or option 6. Okay, let us see.
Sir, by mistake, I clicked one. No, I didn't say that. See that not thing. I
Okay.
think 1, 2 both are same. That's why I
Oh.
did that.
Yeah.
Okay, okay. But you have to be sure, right? Like you just have to read the option.
That's why I did mistake.
Yeah. Okay. Anyway, let us see how to solve this particular question. In order to check for continuity, what you have to do?
Check for left hand limit and right hand limit.
Check for left hand limit and right hand limit. And
the
that is
value
for
of function.
continuity.
Yeah, and the value of function.
And the value of it should be equal to the
Yeah,
value of the function.
all three should be equal.
Correct. Okay, before going to see the solution, I just wanted to show you a flowchart which I prepared personally. So even I will show if I take the revision session, I will again show this PDF. Is my screen visible?
No, sir.
No.
No, sir.
Now?
Yes, sir.
Yes, sir.
Yes, sir. Visible.
So this is small kind of flowchart which will help you to check for. So is it clearly visible or do I have to zoom it a little?
No, sir. Visible, sir.
Visible,
sir.
right? Okay. Okay, what you have to do is,
Yes,
in order to check limit continuity and differentiability at the same time, if you wanted to check at some point x is equals to a, you have to start from computing the left hand limit and the right hand limit at point a. So the first and foremost thing you have to do is this computing the limits of left hand limit and the right hand limit. So if you compute the left hand limit at you have to compute like limit extends to a minus. So you have to come from the left side of a, and you have to see the value of f of x, and that is called as left hand limit. So LLHS, if it is LLHS, and the right hand limit is you have to come from the right side of a, something like more than a value to a. So it's like limit extends to a plus. So the plus side of a, you are coming from the plus side of a, and you have to check the limit value of this function, and it is right hand limit. So once you have these two limits with you, left hand limit and the right hand limit, then you have to check. So what you have to check is whether these two are equal or not. If they are equal, yes, you have to go this side. No, what you can conclude is, if it is no, let's say both the limits you got two different values, then you can directly conclude that limit at x is equals to a does not exist. If one's limit does not exist, you can directly conclude f is not continuous at x is equals to a, and f is not differentiable at x is equals to a, and you will stop. You don't need to check anything. If your left hand limit and the right hand limit are values are different, then we can conclude directly about limit, continuous and differentiability of this particular function at x is equals to a. What if it is yes? If it is yes, that means both the left hand limit and the right hand limit are equal. Once they are equal, what we say is limit at x is equals to a exists. So the limit exists now. Now what you have to do? Which checking you have to do? Once the limit exists, whether this limit at x is equals to a, whatever the value we got, whether it is equal to f of a or not, function value or not. F of a is the function value. And again, if it is no, if it is not equal to the function value, then you can directly conclude that limit at x is equals to a exists, but f is not continuous at x is equals to a, f is not differentiable at x is equals to a. So we do here the limit exists, but it is not continuous and it is not differentiable. What if it is yes? Yes means what if the value, the left hand limit and the right hand limit both are equal, and also it is equal to the function value. If it is true or if it is yes, then what we conclude? What we conclude is f is continuous at x is equals to a. So once we have f is continuous at x is equals to a, next what? So once you are guaranteed that f is continuous at x is equals to a, then we go checking for the differentiability. So in order to check for differentiability, what we have to check is, along with continuity, what you have to check is extra this particular limit f of a plus h minus f of a divided by h. This particular function limit at 0 should exist. So that means limit h tends to 0, f of a plus h minus f of a divided by h should exist. Exist means again the same thing. The left hand limit and the right hand limit you have to check. Those both the left hand limit and the right hand limit should be equal for this function, not f of x function. For this new function, it is f of a plus h minus f of a divided by h. This is new function. So this particular limit should exist. I'm hearing some noise. Vivek, can you mute? Okay. What if this particular limit value does not exist, or if it not exists, if it is no, if it is not existing, then you can conclude that limit as x is equals to a exists, f is continuous at x is equals to a also, but f is not differentiable at x is equals to a. What if this limit exists? If it exists, then limit at x is equals to a exists, f is continuous at x is equals to a, as well as f is differentiable at x is equals to a. And finally, all these three cases we stop. So after computing these three, we will stop. So we have four different cases. Limit continuous and differentiable, not different. Limit does not exist, f is not continuous, f is not differentiable is one case. Limit may exist and function may not be continuous and not differentiable at x is equals to a. Limit exists and continuous, but it is not differentiable at x is equals to a. And limit continuous and differentiable at x is equals to a. These are the only four possible cases when you compute limit, continuity and differentiability at any point for any function. So this is what.
Sir, I have a question. Is there relation between a differentiable function and a derivative of a function?
Yes.
Like if a function is differentiable, then you can take derivative, but if it's not differentiable, then you can't take derivative.
Derivative, correct.
But sir, you can take a derivative of mod x, right?
We can take derivative of mod x. So if
yes.
if you divide it into piecewise function, then you can define derivative of this mod x in piecewise.
How, sir?
See, mod x is actually, it's a piecewise defined function. So mod x.
Okay, you can't draw tangent at 0, right? It's a sharp point, okay.
Except at x is equals to 0, rest of the points it is differentiable.
Okay, sir.
Okay. So the differentiable, if you wanted to write the differentiable function of mod x, it will be like, it will be +1 for x greater than 0. It will be -1 for x less than 0. And there will not be any x is equals to 0 case. So that is how you have to write the differentiable function. If you define your function piecewisely, excluding 0, if you remove 0 from your function and you have to compute the derivative, then we say the derivative of mod x exists.
So, sir, like there is no defined relationship between differentiable function and derivative function, because like it is not a differentiable function mod x, right?
See, mod
But
x
you can
is not differentiable at x is equals to 0, and it is not a differentiable function, correct?
okay.
So if I wanted to talk about derivative of this mod x, then we have to define this mod x in like you have to split mod x like -x when x is less than 0 and x when x is greater than 0. Okay, you have to define two different functions, two different cases, and each of the two different cases you will get two derivatives, different derivatives, and then we say this is how the derivative of mod x will be. So it's like we
Sir, we could
define.
do another thing too. We could write under root x square, because mod of x is usually represented as under root x square, and we can take derivative of that, which comes as like x upon mod x.
X upon mod x.
Wait, let
Acha.
me find where I solved it.
Okay. You are coming. Okay, you are doing like that. Fine. Okay. We will discuss that. Okay. Let us complete this thing, and we will discuss that thing. I understood what you're trying to ask. Okay.
Okay, sir.
Okay. So that is about continuity, differentiability, and limit. If any given function, if a function is given to you, that is how you have to check continuous, differentiability, and limits. Understood? If you understood the flowchart, we can move forward. Okay.
So the flowchart is nicely done. Flowchart is nicely done.
Okay. We will discuss. If I take the revision session, we will discuss there also.
Sir, please share the flowchart.
Flowchart. Okay. We will share it. Okay.
Yes, sir. Please share this document.
Now, which screen is visible? Are we back to our presentation?
Yes, sir.
Yes, sir.
Yes,
okay.
sir.
Okay, now that we have this function with us, in order to check the continuity at y is equals to 0, we have to check the left hand limit and the right hand limit, and both the left hand limit and right hand limit should be equal first. If limit exists, then only we can check for continuity. So the limit value should be the function value at y is equals to 0. So that is what we try to do. So as we know that sin y by y is a well-defined or already given standard limit. As y tends to 0, sin y by y will be 1. You can use, now you know L'Hopital rule. You can use the L'Hopital rule, and you can get satisfied that this particular sin y by y will be equal to 1 as limit y tends to 0. And what we have to do is the limit value should be equal to the function value. So what you have to do, you have to substitute, you have to find the function value at y is equals to 0. So that means f of 0. So what is f of 0 given to us? So at f of 0 means y is equals to 0. If y is equals to 0, our function value is 1. Correct? So that means f of 0 is 1 and the limit value is also 1. So therefore what we can say is f of y is continuous at y is equals to 0. So option 2 is correct. So we are guaranteed that it is continuous. So now we have to check for differentiability. What we have to check? We have to check this particular limit f of 0 plus c minus f of 0 divided by c exists or not as c tends to 0. So it will be like f of c minus f of 0 is 1, f of c minus 1 divided by c. And if you substitute f of c here, sin c by c minus 1 by c. So it will be like sin c, if you simplify this, it will be like sin c minus c by c square. Now, how we are checking without taking left hand limit and right hand limit is because this is a function. Sin c minus c by c square is actually a function, smooth function. You can actually do the left and right, but the left hand and the right hand limit both will be the sin c minus c by c square only. So that is why we know that the left hand limit and the right hand limit. Hello? Any doubt? You can directly compute directly by taking single function itself. So now we are at sin c minus c by c square. If you substitute 0, we will get sin 0 minus 0, which is 0 minus 0 by 0 square, which is like 0 by 0 indeterminate form. So you can use L'Hopital rule. So use L'Hopital rule. Sin c derivative will be cos c, c derivative will be 1. So sin c minus c derivative will be cos c minus 1 divided by 2c. Now again, if you substitute c is equals to 0, you will get 1 minus 1 by 2 times 0. Again, it will be like 0 by 0 form. So what we have to do is you have to derivate it again. So you have to use L'Hopital rule again. Now if you derivate the numerator, we will get minus sin c. And when you divide the denominator, you will get 2. Now if you substitute 0, you will get 0. So therefore the limit value exists. So the limit exists. That means it is differentiable at x, y is equals to 0. Therefore option 4 is also correct. Now the final part. What will be the derivative of f of y at y is equals to 0? Will it be 0 or 1? So both ways we got 1, 0, 0. So you can see here, function value at y is equals to 0 is actually a constant function, 1. So constant function derivative will be 0 directly. You can do that thing. Or even if we compute the limit value, limit of this f of 0 plus c minus f of 0 by c, which is the f dash of 0. Even in that way also we got the derivative of f of y at y is equals to 0 is 0. So options 2, 4, 5 are correct.
Excuse me, sir.
The 6 is not correct?
6 is not correct.
Excuse me, sir.
Did mistake.
Solution part, sir, please. Go back to the solution. How you take sin c by c in place of fc?
F of c.
Yes,
that is how
sir.
the function defined, right? That is how the function is defined, the left of 0 and the right of 0.
Sir, please explain option 5, sir. Once.
Option 5 is actually the, see, this particular limit c tends to 0, f of 0 plus c minus f of 0 by c. This is what the f of the f dash of 0, right?
Yes, sir.
So what value did we get?
0.
0. So the derivative value of f of y at y is equals to 0. Or you can directly do from here. The function at y is equals to 0 is defined like a constant function. So f of y will be 1 if y is equals to 0.
Okay, okay.
You can directly derivate it. So the constant function derivative
Yes,
will be 0.
so now get it.
Okay. And
Yes.
yeah, coming to this, why f of c is replaced with sin c by c is because we are coming from left side of 0 and the right side of 0. From both sides, the function is defined like sin c by c only. So that is why we took f of c as sin c by c. It is not here f of c, c is not 0 here. C is actually coming to 0. So c is actually a value which is very nearer to 0. And we have the function is defined like very nearer to 0, function is defined like sin y by y. Now therefore it will be like sin c by c here.
Okay, sir. Thank you.
Okay. Yeah. Okay. Let's move. And this is the third question. We have given you a 5-degree polynomial, which is g of y is equals to some b5 y to the power 5 plus b4. So b5, b4, b3, b2, b1, b0 are the coefficients of each term. And what we said is g dash of c is the derivative of g at y is equals to c. Okay. So g dash of g, c is just the denotion of the derivative. Again, we have given 4 options here. You have to choose which one of the following options are correct. So I guess 5 minutes is sufficient. If required, I will give you some 1 or 2 minutes for computation.
So I think this Modulus slides are like in the resources by instructors part in the
It's
dashboard.
already there, is it?
Yes, sir.
Oh. Okay. How many of you gone through that?
Not yet, sir.
Not yet. Okay, let's do one thing then. After this question, let me take most important other questions. Maybe some doubts you have. First and later we will discuss 4th and 5th. So as these slides are already available on the portal, I don't think this will be much helpful.
Is week 4 graded solution is available, sir?
Week
5, sir. Week 5 graded solution. PDF, sir.
Is it not released yet? It's already available, right?
Sir, I not found, sir. So which section there is uploaded, sir?
Yes, sir. He's right. Week 5 is not visible on portal.
Okay, let me ask. We will check. Okay, let me check.
Okay, sir.
Okay, meanwhile, you solve this problem. I'll just check whether. It's there, right? Like it's just below the graded assignment 5. Okay, are you qualifier student or term student?
After qualifying, sir.
Okay, just a second. In the term portal, it is there. Let me check in qualifier portal also.
No, sir, it is not there.
Not there, sir.
I've just checked.
Okay, it's not there. It's not there in qualifier portal. It's only in term portal. Okay, let me ask them to add it. Okay.
Thank you, sir.
Thanks to you for bringing this.
So are the quiz 1 solutions available yet? I couldn't find it. I mean,
Quiz
Yeah, it is available.
are available, I guess.
Sir, I did not get the line. Let g dash of c denote the derivative of g at y equal to c.
It's just the denotion. We say. See, g dash of c is actually the derivative value, right?
Yeah, I took the derivative value of g of y.
See, you found g dash of y, is it?
Yes, I took the derivative of g dash.
You took the derivative of the function.
Yes.
And at particular point y is equals to c, the derivative value will be z dash of c. So that is how we denote z dash of c, means it's actually the derivative value at point y is equals to c. That is what the
So
denotation.
I'm supposed to replace all the y by c, right?
No, not all the y by c. Here in options you can see there is g dash of 0, g dash of 1, z dash of minus 1. So what you have to do is you have to compute z dash of 0, z dash of 1 and z dash of minus 1. So these are the denotions we given you. So g dash of 0 means it is the derivative value of the function g at y is equals to 0.
Okay, sir.
Okay. Okay, I just informed them. I guess they will upload it today, by today night or tomorrow morning. You will get week.
So could you please tell them to upload for week 7 also? Because it's not there yet.
Yes, sir.
Week 7 is also not there.
Yes, sir.
Yes, sir.
Week 7 graded assignment solution.
Okay, I will tell that thing also.
So according to, will you be uploading this flow chart on portal, or will you share separately on chat box somewhere?
On the portal.
We will whatever the extra content we are going to share with you, it will always be in the resource from instructors tab. Okay. Or if it is not there, then you just check supplementary content. Any of these two tabs you will get our any new contents or any new something related to live sessions or extra content. These kind of things we will post it there in the respective weeks. So this will, if I upload this, this will go into the resource from instructors of week 8. Okay. Okay. So 22 people have responded for this. So other people are trying this, or shall we move to solution part?
Sir, a few
1
more
minute,
minutes.
sir, please.
Okay. So 1 or 2 minutes granted. And how many of you seen week 9 contents?
Not yet, sir.
Not yet, sir.
Anyone who has just had a glance of week 9? No?
Me, sir, I have seen, sir.
Okay, okay. Nice. Many people are like, pehle ye hone do. Right?
Yes, sir.
Yes, sir.
Yes, sir.
Week 8 math require much practice. We don't get time.
So kind of in dilemma right now to like focus on week 9 or quiz 2.
See, my suggestion is just go through week 9 contents. It's pretty much useful stuff we have discussed in week 9. Okay. Need not worry about quiz 2. Quiz 2 is not that hard. Okay. We have set the paper like medium kind of thing, and anyway we
No,
will
sir,
discuss.
not that hard. Very hard.
Even if we can shift the week 9 date to somewhere 2-3 days late than the week 2.
Everything is very
Yes,
much
sir,
new.
absolutely. Yeah, sir, because in graded 7 there is some typical questions also there.
Yeah, we understand. See, even the last time also we faced the same issue. But if we extend the deadline, what happens is it is very difficult for us to get the hall tickets for you. So we have to take some 6 out of 9 assignments, right?
Yes, sir.
So for that, if we push the deadline of week 9, later once you submit week 9 assignment, then we have to pull out the data.
Sir, even 1 or 2 day would be helpful. Maybe by somewhere by 10th, 12th or somewhere.
Okay, every time, even if there is a chance of 1%, I say let's see. But today I'm telling it straightforward, 100% it may not be possible. See, if I say let's see, and okay, I will push it for 2 days for your satisfaction, but it may not happen. Okay, so there are many background issues for them to post. We have discussed this in the last term itself. Even the last term student faced the same issue. So even they had to do week 9 just before quiz, and we tried a lot for pushing week 9 deadline, but see, we had actually gone with this suggestion that many students unable to focus on week 9 and everything we had discussed in the last term itself, but we hadn't got a fruitful result out of it. So it's not, see, if we keep on arguing about these things, we don't get anything. That is what my suggestion. Just go with the flow without discussing to postpone. Spend some time on week 9. Even after quiz 2, we will spend some time on week 9 for better understanding or anything. So don't worry about the graded assignment week 9. It's just the one assignment, right? So just submit it with whatever the knowledge you have. If you wanted to gain knowledge, after quiz 2, we can have a lot more discussion on week 9 again. And week 10 is pretty much interesting stuff you are going to see, which is graph theory. Yeah.
Sir,
Yeah, Sai Teja.
sir, if I have questions from outside, sir, like I'm solving questions from other books. So where can I ask doubts, sir?
You can ask here, but you have to stay till end, okay? Not in the middle of the discussion. We can discuss
Okay,
at the
sir.
end of the.
At the end, I can.
On-demand session is
Or
free.
on-demand sessions you can ask. Or
Okay,
you
sir.
just post it in the discussion forum.
Yeah.
Okay, sir. Yes.
Which
yes.
book you are referring to?
Sir, actually, I'm referring engineering mathematics. I'm doing, sir.
Okay,
Wow.
okay.
In that
RJ
time,
Agarwal. RS Agarwal, is it?
yes,
RS
sir.
Agarwal. Okay.
So in that these topics are there.
Yeah, correct.
So, but they are little like extra. Like extra is there for that also, sir. Like in limits, they are adding little extra also. So those things I'm not getting properly.
Okay.
So like as sir skipped some topics, no sir. Like log of 1 plus x, all those things they are doing it complicated questions they are making. So I had some doubts, so I thought where I should ask.
Okay, you can ask at the end of the sessions. Okay, so once we done with the agenda, then we can discuss whatever we wanted to discuss.
Okay, sir. Sir, how should I post pictures of the questions, sir?
Yes, sir. Make a group, sir, also, sir, where we can post a question and solve it together, sir, on that group, sir.
Okay. Why not you create one group and just give us
Yes,
the
sir.
link?
Especially on Telegram, it will be helpful, sir.
Yeah. See, you people create a Telegram group and give us the link and we will join directly. So it's like coming from our side, we require many permissions, right? So in order to get those permissions itself, it will take a lot more time. Just create a group, have some good set of people group, and give us the link. We will join. We will join that link, and you can post it there. And
thank you, sir.
Even I just
This
wanted
will be
to
good, sir.
refer one calculus. It will be a good book for calculus. James Stewart. So if you are interested to solve more problems in calculus, James Stewart is one good book you can refer to.
James Stewart, sir.
James Stewart.
James Stewart. Okay.
Yeah. Okay. Let us come back and let us discuss this. Okay. Now we have given 5-degree polynomial, and we given some expressions to you, like p1 is equals to g dash of 0, and 5b5 plus 3b3 is equals to some half times some complicated equation we have given you. So in order to find, or in order to say whether this particular equation is true or false, expression is true or false, what we have to do is you just have to compute g dash of 0 first, g dash of 1 first, and g dash of minus 1 first, because those are the only things involved in this three options. So first find those three, and once you find those three, we will get three expressions. So you have to do some manipulation, some plus minus, some multiplying 2 times or 3 times, and add few things. You just have to do some manipulations, and you just have to try to bring this particular expression. If you are able to bring this expression, it is well and good. If you are unable to bring, it's fine. That is one process. Or else, if you know g dash of 1, if you compute g dash of 1, g dash of minus 1, and g dash of 0, just put g dash of 1 and add it to g dash of minus 1 and subtract it with 2 times of g dash of 0, and you divide whole thing with divided by 2 and see what you are getting. So if it is like 5b5 plus 3b3, done. We are done, and we say option 2 is correct. If it is not, then option 2 is incorrect. Same goes to option 3. So two ways you can do. Either one. So standard, if you ask me the standard way how you have to do is, This is how you have to do. Compute g dash of 1, g dash of minus 1, g dash of 0 and put it in this expression. If left hand and right hand are same, then it is true. If it is not same, then it is false. So that is what we are going to do. So we know the polynomial. Just we have to find the derivative of this polynomial. So how to find the derivative of this polynomial? You have seen, right? So it will be like 5 times b5 into y to the power 4 plus 4 times b4 y to the power 3 plus 3 times b3 y square plus 2 times b2 y1 y plus b1. So this will be the derivative function of this g of y. And just now we discussed what we have to find: g dash of 0, g dash of 1 and g dash of minus 1. So g dash of 0, just substitute 0 here. So what you are going to get, all these 4 terms will be 0 and we will be left with b1. So g dash of 0 will be b1. So option 1 is correct. Option 1 says the same thing. Option 1 is correct straight away. Now g dash of 1 is, just substitute 1 in this function, derivative function. If you substitute 1, we will get 5b5 plus 4b4 plus 3b3 plus 2b2 plus b1. So that is what you are going to get. And g dash of minus 1 will be, just substitute minus 1 here. So alternative terms will get negative values. So because the powers are odd for alternative terms. So minus 1 to the power 4 will be positive 1. But minus 1 to the power 3 will be negative 1. So therefore we will get 5b5 minus 4b4 plus 3b3 minus 2b2 plus b1. Now you just have to add these two. So if you wanted to check option 2, what you have to do, you have to add this g dash of 1 and g dash of minus 1 and subtract 2 times of g dash of 0. That means 2 times of b1. So if you add these two, what we will get? 10b5, this and this will get cancelled. 6b3, this and this will get cancelled. 2b1. So 10b5 plus 6b3 plus 2b1. And we are going to subtract 2b1. So even this b1 term will go off. We will get 10b5 plus 6b3 will be equal to this particular thing. If you divide it by 2, we will get 5b5 plus 3b3. It's just the here and there calculation, just moving, manipulating things. Okay. So 5b5 plus 3b3, you will get like whatever the expression is there in option 2. In the same way, what you do is, you just have to, you just subtract g dash of 1 with g dash of minus 1. So what you will get, 5b5 and this 5b5 will get cancelled. 3b3 and this 3b3 get cancelled. b1 and b1 will get cancelled. We will be remained with 8b4 plus 4b2 and divided by 2, we will get 4b4 plus 2b2. Okay, that is how you can get. Therefore, option 1, 2, 3 are correct. So sorry, I forget what you guys have given. Okay, 1, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 3, 1, 2, 1, 2, 3. Okay, most of you have given 1, 2, 3. Very few have given only 1, 2. Okay, fine. Okay, let us see this one question also. So the distance in meters traveled by a car after t minutes is given by the function c of t is equals to another function f of t cube plus t square plus t plus 1. So this is a function of another function. So this is a composite function, right? We studied in week 5. Composition of two functions. So one function is f and another function is a polynomial which is t cube plus t square plus t plus 1. So here we have given you that f is a differentiable function with domain R. We don't know what f is, but we know the g. So the other g, inside g, this t cube plus t square plus t plus 1 is another function. So this is a composition of two functions and the distance in meters traveled by a car after t minutes is given by the function c of t. Okay, now what I want is find the instantaneous speed of the car after 5 minutes. So that means that t is equals to 5. I want the instantaneous speed of the car. Also it is given that f dash of 156 is equals to 1. I don't know why it is 156. You find why it is 156. Why not any other value? And I want the instantaneous speed of the car. Okay, just try to solve. I will be back in 2 minutes. Okay. Okay. Ranjesh Kumar. Hello. Am I audible?
Yes, sir.
Yes, sir.
कहाँ है रंजीश कुमार?
Yes, sir.
Okay.
Am I audible?
You are audible clearly. Done with this problem?
Yes, sir.
No.
No. Rajneesh. Okay, sorry, not Ranjesh. Why aren't you correcting me? I called your name some other name, right?
Yeah.
You don't want to correct me or what? और कुछ भी बोलने दो क्या है हमसे?
No, sir, not that.
Okay. It is Rajneesh, right?
Yes, sir. It's Rajneesh.
Okay. Half of your name matches with a famous celebrity. Do you know him?
No, sir. Whom are you talking about?
Rajnikant.
Rajnikant. Yeah.
Oh,
Do you know him? Where are you from?
I am from Bihar.
Bihar?
Yeah,
मतलब
Yes,
area
sir.
बोलो.
Aurangabad.
Aurangabad. Okay. How far it is from Gaya or from Patna?
From Gaya, it's 2 hours.
Acha.
Sir, me from Patna.
Oh, you are from Patna. Nice.
Yes, sir. Sir, you are from?
I am not from Patna. I am from Andhra.
Oh.
But many of our instructors are from Bihar, Patna.
Yes, sir. Deepak, sir. Anand Singh.
Yeah. Deepak from CT is from Patna.
Maybe Prashant sir from stats also.
No,
If I'm
he's
not wrong.
I don't remember. But there are many. Yes. Like in stats too, you will get Nikita is from Bihar, Gaya. Sorry, she's from Gaya. And stats 2 and MLF, there is one more instructor, Vishal, is from Patna, Bihar. So yeah, we have some 4 or 5 instructors, including degree level. Okay. So only 18 responses. Okay, let me give
Not
you
able to do that, sir.
okay, let me give you an hint. What
Distance is
exactly this
given.
instantaneous speed means?
dx by dt.
dc/dt.
Yeah, dx by dt. You have to understand it from the base of derivative definition. So small change in x, the ratio of small change in y divided by small change in x is what the derivative is actually. Okay, dy by dx is what the derivative means. So if I have given you the distance as well as the time graph to you, so small change, instantaneous speed is nothing but the small change in distance divided by small change in that time, right? That is actually the c dash of t. So what I wanted is c dash of 5. So I want the instantaneous speed of the car after 5 minutes.
C dash of 5.
So I want c dash of 5. That's it. I want the value of c dash of 5. Even you just have to enter the number, whatever the c dash of 5 value is.
86.
Don't shout.
I did up to that, then I'm confused.
Okay. And later what you have to use? You have to use the chain rule. So this is a composition of 2 functions, right? You have to use the chain rule function. Chain rule here. You know what is chain rule? Nothing
Yes, sir.
related to chains.
Yes, sir.
It is related to functions. Okay.
Yes, sir.
Use
But
that chain.
how we apply this chain rule here, sir?
There are 2 functions, right? One is f of t and another one is consider like g of t. And that g of t is given to you like a cubic polynomial, which is a t cube plus t square plus t plus 1.
Yes, but what is then f of?
Okay, what will be f of g of t derivative?
Above my head.
Above your head.
Derivative of f into derivative of g.
Simply, sir.
Could you just show us the answer? Because I have solved it, but I am nowhere near
Curious
to
to
the
know
answer.
the answer.
With
Nowhere nearer to
85.
Sir, I am getting what, like, shouldn't speed
Ah.
be distance upon time?
It's not, we didn't ask you the speed. Okay, we asked you the instantaneous speed.
Yeah, instantaneous speed is dx by dt according to physics, if I'm not wrong.
Same thing, dx by dt only you have to find.
So what, I'm not
This is the
getting like
answer
what
you
should
have
I...
given, right?
Yes, yes.
No, I haven't
I got it.
submitted my answer because
You
I'm
haven't?
not. Yes,
Okay. Okay.
I'm not sure what my function t should be.
What your function?
CT is like distance, right? Because it is in
It is the
meters.
distance. Yeah, correct.
And what is my time? Like time function. I don't have a time function for this.
T is actually the
Equal to
time.
5. No?
Just a second. Just 1 minute. Okay, sorry. Yeah. See,
Sir, please help to do that math.
do that.
How to proceed after that that 86 after putting the value of 5, then what do we have to do?
See, I guess you are
Differentiate and put
confused with
value.
this new variables like C, T, like this, I guess.
I'm just not getting the part what my time function should be.
See, time is not a function actually.
Speed changes according to time, right?
Yeah, T is variable, right?
So
T
there
is
should be
nothing but
function.
x-axis.
Okay. Like
Here T represents x-axis. So x, you replace it with T. And whatever the time you are seeing, see 0 represents at time T is equals to 0. 1 represents on this line at time T is equals to 1. T is actually the variable. There is no function to time.
okay, t is changing constantly.
T changes. If T changes, with respect to T, D changes. The distance is changing. So initially it may be at 0. So after 1 second, the car might have moved to some other, has traveled some distance, right? Might travel some. That particular function is nothing but C of T is given to you. At time T is equals to 1, C of 1 is the distance traveled by the car.
Okay, okay. I'm getting it now.
Okay. So C of, somewhat it may be like
Sir,
this,
but
or
this is a composite function, right?
yeah, this is a composite function.
So f can be one function and g of
Ultimately C of T is the function, right? C of T is the function to you.
Yeah,
If
so
it is
distance
composite or exponential, or I am not getting into what exactly that function is. I am just referring what C of T means. This particular C of T is actually representing the distance after time T. So initially the distance at time T is equal to 0, it will be 0. But as we move along, as the time progresses, the distance actually changes. The distance of the car traveled will be keep on increasing. The distance will be more and more, right? You can't negative travel. So at time T is equals to 1, you may reach some 10 meters ahead. After 2 seconds, you may reach some 30 meters ahead. After 3 seconds, you reach some 60 meters, like this. So we don't know the function yet. But this particular C of T represents the distance after time T. So it may be something else. That particular C of T is given to you as some function of some composite function, f of g of t kind of thing, maybe. So this particular C of T now became f of g of t. It's the function of a function. It's not single function. It's a function of a function, which we call it as composition of two functions. So here nothing changed. C of 1 represents the distance traveled by it after 1 second. Even the same thing, f of g of 1 is also same thing. F of g of 1 is the same thing which is equals to C of 1. Also it represents the distance traveled by the car after time t, after 1 second or something. Okay. Now we have given you g of t as some cubic polynomial. So we have defined this distance as f of t cube plus t square plus t plus 1. This is what we given you. But instead of going to this directly, let's come and discuss in terms of c of t only. Now I just wanted to find the instantaneous speed at t is equals to 5. So I just wanted to find the speed of this car at this particular point. So when we have the graph between time and distance, so this particular thing represents the distance. In order to compute the speed, what we do is
We need to find slope.
Slope, or if you wanted to
Or we can
understand it
differentiate.
physically, if you wanted to understand physically, in this particular small interval of time, how much distance this particular thing has moved. Correct?
Right, sir.
So that particular distance dy by dx or dt. So within the small interval of time, how much distance this particular car has traveled. So that distance by time, that small distance dy divided by that small time dt is what the instantaneous speed is. So this dy by dt is nothing but, technically in recent times, this is y dash of t. Now just put it back, like bring c into the picture. So this is dc by dt. This will be equal to c dash of t. So c dash of t represents the instantaneous speed, which is nothing but the distance traveled, small distance traveled within the small time. Okay. Now we have to find c dash of 5. So we wanted instantaneous speed at t is equal to 5. So what we have to find is c dash of 5. So this is what we have to find. So in order to find this, we have to do some particular what we say, some things. So we know c of t is this. We have to find c dash of t first. So in order to find c dash of t, this is nothing but f of g of t whole derivative. So using chain rule, this will be f dash of g of t times g dash of t. Correct? Using chain rule, the inside function.
Yes.
F dash of g of t times g dash of t. What if we have f of g of h of t whole derivative? This will be chain wise. It will be like chain wise.
Rule, sir. Yes.
It will follow first f dash of
We have
g
to
of
apply
h
chain
of
rule
t.
twice.
Yeah. So this will be like f dash of whatever the function is inside. It will be same. It will take the derivative of f dash f function times whatever the inside of f is there. For that it will be derivative. For that derivative you have to take. So this will be the derivative. Now what is this derivative? So just now we have seen. So this will be equal to f dash of g of h of t times this will be g dash of h of t times h dash of t. So this is a chain wise. It will be like chain. So it will start from one function. It will go to the next function derivative, likewise. It's like an order. It's like chain. So for f dash, there will be g and h. For g dash, it will be h, and h dash, it will be h, nothing. It will be like chain. So ultimately, we know we have to find this value. No. So what will that be? C dash
Can you
of
please
t
repeat
will
it
be.
again?
Huh?
So can you please repeat it again? I mean, it's not clear.
So it's like, this is like composition of two functions. Okay. You have to, it's like inside one function there is another function. So for that particular kind of functions, if you want to take the derivative, what you have to do is you have to take the derivative of the outside function, keeping inside function same as it is. So you have to compute f dash of g of t times you have to compute the inside derivative g dash of t. Similarly, if you have three functions to you and you have to compute one function inside another function inside another function, you have to compute the derivative of it. You compute the derivative of the outside function keeping inside function as it is times the inside function's derivative. So it will be like f dash of inside function, it will be as it is, times the next function you have g. So you have to derivate the g dash keeping h of t as same as it is, and later you have to take h of t and derivate it. It's like chain rule. So one good example is okay, let me complete this. Okay, let me discuss that example also. So if I wanted to find the derivative of this function log 2 sin x sin x square. Okay, so this is one function. This is composition of three functions. Log base 2x is one function, sin x is one function, x square is another function. So this is actually, if I say this is f of x, this is g of x, this is h of x, this will be like f of g of h of x. So you can compute this easily. So this will be, ultimately this will be f of g of h of x. And if I wanted to compute the derivative of this function, if I want the derivative of this function, what I have to do is I have to take the derivative of log function first. So what will be the derivative of log function? Okay, let us use e first instead of going to base here.
Yes, sir. Then we have to change the base again.
Again you have to use the base. Okay, log base e. So what is the derivative of log x? ln x.
1 by sin x.
Okay, 1 by x is the, this derivative will be 1 by x, right? If
Yes.
f of x is equals to log
x.
Okay, I will write it here. If f of x is log x, ln x, what is f dash of x?
1 by x.
If your g of x is sin x, what is g dash of x?
Cos x.
Cos x. If it is h of x,
Then 2x is 3.
what is h dash of x? 2x.
2x. Sorry, 2x.
Correct?
Yes.
If f of x is ln x, then f dash of x is 1 by x.
Yes.
Now your f of x is not, if our f of, now here it is f of g of h of x. It's not x inside. Inside there is g of h of x. Okay. You just replace x with g of h of x. What will be your f dash of x? It will be like 1 by x. So that means the first derivative will be, so this value is f dash of g of h of x times g dash of h of x times h dash of x. So this f dash of g of h of x will be 1 by g of h of x, whatever the g of h of x is. So g of h of x is sin x square. So the derivative, this particular f dash of g of h of x will be 1 by sin x square. So if you don't understand it, it's okay. Now I will explain it with values. Okay? So you have f of x here, but we have the function as f of sin x square. So that is what, right? ln sin x square we have. So we have f of sin x square, which is ln sin x square. So for x, it is derivative 1 by x. For sin x square, you just replace x with sin x square. you will get f dash of sine x square is 1 by sine x square. Now next is we have g of x as sine x, g dash of x is cos x, but we have g of x square here. So it will be like g dash of x square will be cos x square. And finally we have h dash of x as 2x. Now you just have to substitute this, this and this. So identify this. What is this? This will be 1 by sine x square. What is this? What is this? This will be cos
Cos
x.
x square.
So ultimately the derivative of that function will be 1 by sine x square, and you have to take the derivative of this, which will be cos x square, and then you have to take the derivative of this inside
2x.
one, then that will be 2x. So one function, after that another function, after that another function. So it will be like an order. So this is what the derivative of this particular function is. Okay. Okay. So that is how you compute using the chain rule of derivative of a composite functions. So now we have you have to find c dash of t. It will be like f dash of g of t times g dash of t. So f dash of g of t. So c dash of t will be f dash of g of t is actually t cube plus t square plus t plus 1. And g dash of t is derivative of this function. This will be 3t square plus 2t plus 1. So this will be c dash of t. We want c dash of 5. So just substitute 5. Two times 5 plus 1. And this is f dash of, yeah, if you compute it, it is 125 plus 25, 150. 150 plus 6, it is 156. Times, this is 25, 375 plus 10, 85, 86. Correct? Now we got c dash of 5 as 86 times some f dash of 156. So let's go back to the question.
It is given 1.
So in the question, if you see, f dash of 156 is given as 1. So if it is 1, our c dash of 5 will be 86.
86.
So that is
Yes.
what the solution is also about. The instantaneous speed of the car after t minutes is actually c dash of t. So c dash of t is nothing but f dash of the same function inside times the derivative of that function. So it is here there is a mistake. It is plus 1. So 3t square plus 2t plus 1 it is. So use the derivative property of composition of two functions. So the instantaneous speed after 5 minutes will be c dash of 5, which will be f dash of 156 times 86. F dash of 156 is given as 1. So therefore the answer will be 86. Okay.
Nice
Yeah,
math, sir.
Nice explanation, sir. I have solved this question in like 2 minutes, but I have done right things, but the explanation thing, how did it explain
Okay.
this? Now I get it, sir.
I think
Because the
I can
similar
take it.
questions are also there in physics, just to find, differentiate, and plug in the values and get the instantaneous speed. I solve it in that manner, but how it is approached, now I get it, sir. Nice
Okay.
explanation.
Okay. Okay, thanks. And this is final question I have, and I don't think we should spend much time on this. It's actually, it is given like a function to you, polynomial function, mod polynomial function. And we said m is the slope of the tangent of the function p of x at point x is equals to half. So what you have to do is you convert this mod. Every time if you give you mod, you just try to remove that mod using piecewise function. So you just identify how the function behaves at around x is equals to half. So if you identify that, our mod will vanish off and it will convert to be a cubic polynomial. And from there, I don't think this is much difficult thing. Just give it a try. Just spend 2 minutes or 1 minute time to solve this. So m is the slope of the tangent of the function p of x at point x is equals to half. I just want the value of m minus 3 by 4. Okay, I said to try. Okay. I can see only 3-4 responses. Is it that hard, or you are not even trying in everyone?
Trying, sir.
Trying, right? Okay. Okay, try to give the answer. Okay. Okay. I don't feel more than 2 minutes I wanted to spend. Okay. Anyway, those who are done, okay, it's fine. Those who haven't done, it's okay. Let us discuss the answer for this, because I just wanted to take some questions from normal open session kind of thing. It will be useful. Okay. Or
Okay,
you just
sir.
wanted to try this only?
I have tried, sir, but I don't know it is correct or not.
Okay. What answer did you give? Oh, we have very large interval, minus 71 to 100.
God, sir.
Nice. Which value did you give, Saad?
Around 20, sir, if I'm not wrong.
I got 41, sir.
Not exactly, sir.
Where is your response? Where is
Sir, I
20
got
here?
41.
Okay, many, not many. This is very vague sample. We have taken only 15 samples.
Yes, sir, not able to.
Okay. First and foremost thing, what you have to do is try to remove the mod. And also, if you see the question, we are actually playing around x is equals to half.
Right, sir.
So no need to consider the whole on and whole domain. No need to look at the polynomial function of whatever the p of x is. You just try to get the p of x around half. X is equals to half. That is sufficient. Around x is equals to half, the inside one, mod inside one, will be positive. Correct? X times x minus 7 times x minus 8. Around x is equals to half, it takes positive values. So if you draw the graph of this polynomial x times x minus 7 times x minus 8, you will identify it. Am I correct?
Yes, sir.
See, the roots are at, okay. So it is given mod of x times x minus 7 times x minus 8. Okay. So if you want to remove this mod, what we have to do? You have to define it in
Sir,
the
I was
intervals.
doing like mod x equal to root over x square kind of thing that I'm using this way to do the differentiation.
Root over
X into x minus 7, x minus 8 whole square. Total whole square.
I
Yeah.
didn't get this. Where did you got this thing?
YouTube, some Google pages.
Okay.
Sir, it is taught in JE. When you are doing JE, it's taught.
Okay.
It is taught there.
Again, for this, if you compute the derivative, there will always be mod again, right?
Yes, sir.
Mod of.
Down one is mod again.
Mod is in its denominator.
Okay, what will you get then? Like, how will we, again? Anyway, you have to deal with mod again.
That's why do not reach any places where to solve this thing.
See, mod function is actually what it makes is any function inside it. What it actually gives us output is, even though it
Positive.
takes negative value, even though it takes positive value, it gives us the same positive value. It actually
Yes.
just changes the sign of the inside function.
Yeah, I don't know how to derivatives, how to differentiate mod function.
How to differentiate mod function?
Yeah,
How?
I don't know.
You don't know. Okay. So in that case, what we have to do is we have to split into intervals and try to remove the mod. For that, you need to draw the graph of this polynomial. So you just have to see in which interval this polynomial is positive, in which interval it is negative. In the intervals it is negative, you just change the sign of it. You just take negative out. You just take one more negative for it. So that is what we do, right? So for f of x is equals to mod x, what we do? So when x is greater than 0, it takes positive values. So when x is greater than 0, we as it is take x. So we take
That
x
means
as it is.
from 0 to 7, this is positive. The graph is positive.
From 0 to 7, the graph is positive.
Yes,
so what you have to
according
do,
to the graph.
You just, so for this, if x is negative, it takes negative values. In order to make it positive, what we do is we multiply minus to x and we make it positive. Correct? So for f of x is equal to mod x, you can split it like, you can define it like piecewise. So both the values are positive values here. So even here also what you have to do is, you just have to consider it like intervals. If it is positive, the value is positive, then you take as it is. If it is negative, you take negative sign in front of that value. So for that, we have roots as 0, 7 and 8. If you draw the graph of this polynomial, it will be like this. Right?
Yes.
So in the interval minus infinite to 0 and in the interval 7 to 8, this is negative.
This is negative, yeah.
So what you have to do is you have to take minus of x times x minus 7 times x minus 8 in the interval when x is less than 0. And when x is between 0 to 7, you have to take the function as it is. You don't need to change the sign. It is actually giving positive outputs. So you just have to take it as it is. So the mod graph will be like this. So only on the positive side. Okay. When x is in between 7 to 8, when x is in between 7 to 8, you have to take negative in front of the function inside, because it is actually giving me the negative outputs. In order to make it positive, I multiply it by minus 1. And when x is greater than 8, I have to take as it is because it is actually positive. It will give me positive value. So this particular p of x, mod of this, can be split into like this piecewise. So this function and this function is same. But what additional thing we get from here is you can actually differentiate it piecewise. So you can differentiate this function, you can differentiate this function, you can differentiate this, everything in respective to their intervals. Okay. But we don't need all of this.
Then at the point 8,
at the point
8 is open, right? At the third one,
Okay.
7.
Equal.
Okay.
But the thing is, derivatives, see, at these points, if this is the function given to us, at this sharp bending points, we don't have derivative, actually. Okay, at x is equal to 0, x is equals to 7, x is equals to 8, derivative does not exist. Okay, apart from that, all other points you can have the derivative value. But we don't need all these things in order to answer that particular question. What we actually require is, we are actually asking you the slope of the tangent line at point x is equals to half. So I want the slope of the tangent line of this. So I just want how this p of x is behaving around this. So in the interval 0 to 7, my p of x will be positive only. So mod can directly be removed. So if you remove mod, you will get the function as x times x minus 7 times x minus 8, which is a cubic polynomial. So you just have to differentiate it directly. So this is p of x you have. You differentiate, you will get p dash of x. And then what you have to do, you have to compute p dash of half. So p dash of half is the slope of the tangent, which is m. And we ask you the value of m minus 5 by 4. So this is p dash of half minus 5 by 4. That's it. So these all things are pretty easy. So that is what we did in the solution. So you see, what you have to observe is, main thing is, in the interval 0 to 7, my polynomial my function p of x is actually x times x minus 7 times x minus 8 only. You can directly remove mod because it actually gives me the positive values. Inside thing will always be positive around.
Yes, 41. Huh?
In this interval 0 to 7. So if you simplify it, you will get x cube minus 15x square plus 56x something. So for that you find p dash of x. So if you compute p dash of x, it will be 3x square minus 30x plus 56.
Even I did up to 3 by 4 minus 15 plus 56. That m, then we have to 3/4 keep it this side, then the answer will be here.
Correct. So you get p dash of half as 3 by 4
I did up
plus
to
40.
up to that one only.
Okay. So okay, p dash of half you got 3 by 4 plus 41, right? So that is m value. So 3 by 4 plus 41 minus 3 by 4 is the value we asked you.
Yeah, the last part of differentiation. Got it.
So from there we get answer as 41. Okay. Yeah. So that's it I have from the slides. So the people who just wanted to attend this session, we are done here. So thanks for joining, and we will meet in the next session. Those who have small doubts, you can stay back. I will stay back for 5 to 10 minutes more.
Sorry, sir. Could you just explain me this line? Observe that p of x, like, how did you get the condition if x is like greater than 0 and less than 7?
See, that is what we just now we have explained, right? So p of x will
Yeah,
be
I
positive.
get it. For x equal to 7, the whole equation becomes 0. I get that point. That is that the reason?
No, that is not the reason. So we are just trying to remove mod here. How you can remove mod? If it is positive, inside thing is positive, you can take as it is. If inside thing is negative, then you take minus of that negative to make it positive.
Yes.
In this interval 0 to 7, the inside polynomial is actually positive. So what you can do is, you can directly remove mod without taking any sign change. So that is what we taken.
So
We
for
taken p of x
the
directly.
interval of 0 to 7, we took the value of the function as it is.
As it is. We just removed mod because the function values are all positive in this interval 0 to 7. Why we took only in this interval? Because we are worried about x is equals to half, and that x is equals to half will be in this interval.
Okay. I needed that point. Thanks.
Yeah. Okay. Okay, officially we are done. And is he there, that Naga Teja or someone? I don't think.
Sir, can I ask a question?
Yeah, Abhijit Ghosh, you can ask.
Sir, this is from the graded assignment, but I just want the concept that if you have two functions fx and gx, and how is it that 1 plus fx to the power gx is e to the power fx and fx gx? Where do we get all these formulas?
Where it is given?
I mean, of course, this is a formula, but I did Google and all I figured out. But I mean, this kind of, there are many formulas like this. So how do we tackle these problems?
Did we given it in graded?
Yeah, it is there in question number 13. To find continuity, and one of the expression is given like that.
Okay, one of the expression is like
It's question number 13 actually.
13. I am just seeing that 13 question. Okay, you said something. Okay, let me try to prove that directly. First, let me assure that you said whatever you said is correct. Okay. You said 1 plus
fx whole to the power gx is equal to e to the power fx gx
times gx, is it?
Yeah.
This is not even true for constant functions only. If I take f of x is equals to 1 and g of x is equals to 1, how this is getting true? Base case. Maybe let us call it as a base case.
I think it's they're taken into a logarithmic series and then breaking out. There are some limits, of course, in this expression.
I think it is extends to infinity, maybe.
Infinite, yeah. That may.
Then it will be 1 power infinity form.
Yeah. So in exponential cases, what we studied in limits is, if you have limit x tends to infinite f of x is equals to f of c, then limit x tends to infinite e to the power f of x will be e to the power f of c. So some function. This we studied, right? In week 7, I guess. Yes, no, never.
I'm trying to figure out.
Okay.
Yeah.
So it is given like function, I guess. So function of some sequence. Okay, the function value will also go to there.
Right.
So it's like exponential function here. So the same thing you can use it. So this particular thing, I can write it like this. So ln, okay, log e to the base e is 1 only, times 1 plus f of x power g of x. I can bring this log e to the base e, right? This is actually 1. It won't change anything. I can write it like this. So this is actually product times log e to the base e. I can take this particular thing to the power of e. So if I have a log some x, can I write it like log x power a?
Yeah.
Correct. So this is actually, I can move this to whole power. I can write it like this. Okay, not that thing we are using. Actually, this thing we are using. So a to the power log x to the base a is x. Will you agree? Is this true? This is true, right?
Yeah.
Okay. So this e to the power log something to the base e is actually this something.
Yeah.
So now this will be equal to limit extends to infinite e to the power this. And this I can write it as limit extends to infinite e to the power g of x times log e 1 plus x log e 1 plus f of x. Correct? Okay, till now it is okay.
Yeah, now this log 1 plus x, they've taken a logarithmic series, I think, and broken it down, and then
Okay, this they have taken it as series. Okay, log 1 plus x will be 1
1 plus x
minus
plus x by 2 x squared.
1 plus or 1 minus?
I think it's plus minus.
Log 1 plus x is plus only. Okay, 1 plus x square plus Taylor series. You can use Taylor
Taylor
series.
series, right.
Yeah. So you will get, I guess, the same thing. Log. Yeah.
But
1 plus
derivation
1.
is okay. I'm just asking, like, how do we do all this? I mean, of course, after spending 2 hours, I got to know this, but
See,
I mean,
if these kind of things are required, we will give you like standard limits. Bolke, we will give you. These are the standard limits you have to use. Okay. If required, we will give you the standard limits. Standard limits like sin x by x.
But for this question, nothing is given. I mean, it's just told to prove the continuity.
See, for this question, graded question, you can actually do it at home, right?
Okay.
You can use whatever the resources you can.
Correct.
Right? Yeah.
Sir, excuse me, sir.
Exactly is the question.
In question number 8 of graded assignment, sir, is the question correct, sir? I'm getting 114 plus b plus a. But it's given find the value of 114b minus a.
Question number 8.
8, sir.
Question number. Just a second. Consider a function f r2 are defined as
Sin 14x plus a sin x.
Okay.
Divided by 19x cube.
So what is the doubt you?
I'm getting the value as 114b plus a. Whatever the answer may be. I'm talking about only the question. But here the question is find the value of 114b minus a. Is it right, sir? Question.
Yeah, the question is 114b minus a is the question, correct? You are getting what you are getting like
114b plus a. Almost 10 times I did, but every time I'm getting 114 plus a only. B plus a.
Same with me.
It can never be minus a, sir. Repeatedly I have cross-checked.
Okay, let me take different values and compute it. Okay.
Okay.
All
Yes,
the
sir.
values you have.
In the numerator, you better take 2 sine functions, sir. Denominator
No, I just change the values.
Okay, sir. It's up to you.
So let me take what you have sine
14x.
Okay, I will take sine 5x.
Sine 5x plus
a
sin x.
Okay. Divided by what you have?
I have 19x cube. Better you take something around 6x cube you take or 17x cube. It's okay. Okay, sir. No problem.
So this question is also ungraded. This what you are writing, sir.
Yes, it's from graded only. But the thing is, I'm asking, is there any correction in the question?
I don't think this will be there.
Yes, sir. Not there.
Because I only gave the values.
No. These numbers are not there. Definitely.
Okay,
It is,
with this x not equals to 0
and this is x equal to 0. It's given f is continuous.
Okay.
Oh, you have to change accordingly the value also. Okay, it's okay.
So what you have to do, limit x tends to 0 minus and 0 plus. Both are same only, right?
Both are
You
same
just have
only,
to
no,
check.
sir?
Yeah, you just
We
have
will
to
go
check
for
the
2
direction.
times L Hospital rule.
So get sin 3x plus a times sin x divided by 4x cube.
Yes.
So 0, it will be like 0 by 0 form.
Yeah.
And you can
It is
go.
3 cos 3x
Okay, it will be 3 cos 3x
plus a cos x
a cos x.
by 12x square.
4 3 is 12, 12x square. Correct.
Again, we'll go for the same formula. Minus 9 sin 3x.
Wait. If you want to go for the same formula, you see, the
Oh.
denominator is 0 anyway.
Okay, numerator is not 0.
Numerator is not 0, right?
Yeah.
So then
Okay.
we said
Okay,
limit
okay.
this. Okay.
Yeah, I got it, sir.
Now what you have to do is you have to find the corresponding value a.
Yeah.
Such
Got it.
that the numerator.
Yes, sir,
Okay.
got it. But repeatedly, what I did is I have gone for the 2 times applying the same rule. That's where I went wrong. Yeah.
That is why
I
I
got
said
it. Yes.
L Hospital can only be applied
For 0 by
for
0
guarantee
or
that,
infinity by infinity. Indeterminate forms.
indeterminate
Yeah, I know.
forms
Sir.
only.
Yeah. Thank you, sir.
Okay, then we can wind up the session today and we will meet you on the next week topics.
Okay, sir. Thank you, sir.
Yeah,
Thank you, sir.
Thanks a lot and have a good day.
Thank you, sir. Just to sir remind you to upload the notes of the like flowchart and everything.
Yeah, flowchart I will upload it. Okay. Maybe you will get by today or tomorrow morning. By tomorrow afternoon, before tomorrow noon, you will get it. Okay.
Week 5 plus greater solution also, sir.
That
five
thing
and
I
seven both.
already
Five and seven.
informed. I already informed the team. They will upload. Okay. In the
Thank you
call.
so much, sir. Thank you.
So, sir.
Mm.
Sir, I have a small doubt. Can you please address it? It's from activity question 8.4, question 8.
8.4 question 8 is it? Just a second.
Yes.
Okay, 8.4 question number 8. Okay. So using the linear approximation of f of x is equals to 1 plus x whole to the power 4 at x is equals to 0, approximate value of 1.01 whole to the power 4. Is that the question?
Yes, sir. Sir, my doubt is, sir, Vicky sir has already solved this question, but he did something which I couldn't understand. He took for x equals to 0.01 in some step, which I couldn't understand.
Okay.
Can you please solve it? It's a small.
Yeah. Okay. Let me solve this and we will end the session. Okay.
Thank you.
Okay. See, first and foremost thing is you just have to understand why we are using this linear approximation. What this linear approximation is bestly used for. Why is this useful? Any ideas before you study something? Like we have studied this linear approximation. Correct?
Yes, sir. It is used to find.
Fine. So from the name itself, okay, you don't need to worry. From the name itself, you can get something. Linear approximation. So what we are going to do is, this is very much helpful. If you have some complicated function, let me say f of x is equals to some x square sin x plus root over x cube minus 1 plus something like another function log of x cube plus 1. So this function you have, okay? And at x is equals to 0, very easy to find. You can see f of 0 is actually very easy.
Yes.
The first term is 0, next term is minus 1, and the next term is 0. So log 0 plus 1 log 1 is 0. So actually f of 0 is -1, you can directly compute. Correct?
Yes, sir.
But what if I ask you to find f of 0.001 value? Is it very easy to compute if you just substitute it here?
No, complicated very.
So if you wanted to substitute, you know, sine 0.001 in order to compute with hand. Okay, now that you have machines and you just put it, you will get it. I'm not saying that. If you have f of x function in your hand, this function in your hand, and you don't have any mobile accessories with you, or no machines are given to you, you just wanted to find or approximate the value of this function at x is equals to 0.001. Is it easy to compute or difficult to compute?
It is difficult, sir.
It is difficult to compute.
Difficult.
What this linear approximation tells you is, it actually approximate whatever the function is, it actually approximates. So if this is the function, this is not a function. Okay, this is the function. So here you just wanted to approximate, you know, this value. It is very easy to compute this value. Okay, let us say it is very easy to compute this value, but you just want the function value here. What it tells is, linear approximation, what it tells is, actually around this interval you can actually approximate this curve to some straight line. So you can actually say that whatever the values this straight line takes in this interval, actually the curve also takes very much nearer values only. You don't need to worry about the exact approximations. You can actually approximate by considering this line, this particular line.
Okay, sir.
Okay, that is what linear approximation means. We are actually approximating the given function around some point, and that approximation is actually a straight line, which is a linear line. Okay.
Yeah, so got it.
Now if you understand this, we have given you f of x is equals to 1 plus x to the power 4. So now f of 0 is very easy to compute, correct? Which is 1. What we asked you is f of 1 is very easy to count. For this we need f of 1. F of 1 is very easy to compute.
Yes, sir.
Correct? F of 1 is something like 1 plus 1 to the power 4. That will be 2 to the power 4, which is very easy. But what we asked you is, we asked you 1.01. Correct?
Yes.
So f of 1.01, or we wanted 1.0, not f of 1.0. We asked you the value of f 1.01 to the power 4. This is actually 1 plus 0.01 to the power 4, and this is actually f of 0.01, this value.
Yes, sir.
Correct? See 1.01, I just split it into 1 plus 0.01.
Yes, yes.
Correct? Now you see, this is actually, if I substitute 0.01 here, this will be like 1 plus 0.01 to the power 4. So that means f of 0.01 is nothing but 1 plus 0.01 whole to the power 4, and this is nothing but 1.01 whole to the power 4. So now I wanted to find the value of this, but this thing is, we asked you to approximate using the linear approximation. Okay, so what you have to do, so you have to approximate the value around 0. So we need 0 actually. Okay, you can actually see we wanted the value of this function at 0.01, right?
Yes.
Which is the nearest easy value to be found in order to approximate?
0.
0. At x is equals to 0, we know the function. And if we find the linear approximation at x is equals to 0, if you substitute the if you substitute x is equals to 0.01 in that linear approximation value, whatever the value you get, it is very much approximate value of this function f of 0.001. Will you agree then?
Yes, sir, totally.
So the function will be somewhat like this, and the linear approximation to the point x is equals to 0 will be something like this, and at 0.01 more or less the value is very much approximate.
Yes, yes.
So ultimately you have to approximate, you have to find the linear approximation at x is equals to 0. Linear approximation at x is equals to 0. How do you find that? It is actually the tangent line. The linear approximation is nothing but the tangent line. Correct?
Yes, sir.
So this can also be proven. This is also proven. So the best linear approximation line is actually the tangent line. Any other line is not the best approximation. So you can get it from there. So y minus f of 0, f dash of 0 into x minus 0. From here you get y or L of x or anything. This is the linear approximation. F of 0 is 1. F dash of 0 is, what will be f dash of 0? 4 times 1 plus x whole cube. So f dash of 0 is 4.
4.
So it will be 4 times x. So y is 4x plus 1.
Yes. 4 is.
So this is the best linear approximation. So even y of 0, 0, 1 is actually f of 0, 0, 1, which is equals to 1.01 whole to the power 4. So we wanted to approximate this value. So it is enough to find y of 0.01. So it will be like 4 times 0.01 plus 1. So this will be 0.4 plus 1. This will be 1.4.
1.04, sir.
1.0.
Yeah,
Okay, 0.4. This will be 1.04. So if you compute this value directly using calculator, what will you get? 101 to the power 4. Somewhere very, very near.
Okay, now got it. Why we are taking 0.01?
So so the value is 1.0406 like this. This exact value of this is 1.0406 something. And even the linear approximation value is also 1.04. So pretty much approximate value. So it is approximated to 2 decimals. Okay.
Okay.
Yeah, this is the usage of linear approximations. Main usage of linear approximation. Here the function is only 1 plus x to the power 4. It is easy actually. Correct?
Yes,
Even
sir.
1.01 to the power 4 is very much easy to compute. What if the function is given like this? Whatever I discussed. This is pretty much difficult, right?
Yes, sir.
For these cases, finding derivative is easy. Derivative at x is equals to 0. Linear approximation is very. Okay. If you are interested, you take this function only and compute this value. Approximate value of f of 0.001. You can do it on hand on paper directly. No need of any calculators. Approximate value you will get. And also find the exact value. Pretty much it will be equal. Okay. 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 Fine then. Have a great night and thanks for joining.
Thank you, sir.
Bye.
Night.